Victor, Elizabeth, Vanna. Vanna. Hey, Ashley, Bishop, and Denise. All right, find the factor 432. Rules of divisibility. So we're going to start with a little bit about the rules of divisibility, but it's an actual part of this first chapter 8, from chapter 8. So we're not going to list them all out until we formally get to them in chapter 8, but we're going to talk them through. How do we know something's divisible by 2? What's the key to dividing by 2? What do you look? Say it louder. Huh? What's half? Well, there would be a half. You can take half of it. But what do you look for? What is the, when you just look at a number, how do you know you can divide by 2? If it's even. If it's even. So 0, 2, 4, 6, or an 8. If it's in the 0, 2, 4, 6, or an 8, you can divide by 2. Okay? Divisibility with a 3. This is divisible by 3. How can you check to see if 3 works? Just by doing something quick. Without actually dividing. Anybody know? Besides me. Yeah, this is going to come up when we actually lecture on it, but if the sum of the digits, so what is sum going to do? When you hear the word sum, how we think of the digits, so the numbers in the number, the digit, if the sum of the digits, so 4 plus 3 plus 2, so 7 plus 2 is 9. If the sum is divisible by 3, you can divide the entire number by 3. 3 will work. 3 goes into it. So 3 goes into 432. So 2, it's even. 3 1. The rule for 4. All these rules are kind of different, but then you can kind of mix and match a few of them. But the rule for 4 is if the last 2 digits of any number are divisible by 4, then the whole number can be divided by 4. So if you had 9,371,256, because 56 is divisible by 4, that whole number can be divided by 4. Forward. Okay. How do we know something's divisible by 5? Or 5 or a 0. So if it ends in a 5 or a 0, we can divide by 5. 5, 10, 20, 25, 30. 5 goes into all of it. 5 or a 0. 6. Now, think about what a 6 is. 6 is equal to 2 times 3. So if it's going to be divisible by 6, it has to be divisible by 2 and a 3. And since we already checked for 2, because it's even, and we already checked for 3, because it adds up to 9, and since 2 and 3 both work, I can use 6, which is a bigger number, which gets me to a greater common factor. So 6 works. So if 2 and 3 both work, 6 is going to work. For 8, you would have to look at the last 3 digits for 8. 4 is the last 2 digits, 8 is the last 3 digits. So now it depends upon, do you know the multiples of 8? Well, 256 is divisible by 8. And I'm looking at it as 256. Well, 8 times 3 is 24. 240 if you use 30. 8 times 30. And then you have 16, and 8 will go into 16. So yeah, I'm not doing the entire division. I just need to do a quick check. So 8 goes into that whole big 9 million, except 37,000. Okay, 200. 9. If the sum of the digits is divisible by 9, then you can divide by 9. So instead of using 3, I could have used 9. Right? Now, in and out all of this stuff, you can also mix and match a few things. 9 goes into this, and it's even. So that means 2 works and 9 works. I can divide this by 18. 18 is going to work. Well, wait a second. You said 9 works, but didn't 6 work? 9 times 6. Shouldn't I be able to use 54? Well, wait a second. 9 is 2 of the 3s, but 6 is another one. Maybe like I'm overlapping a 3. I'm using 3 in the 9. I'm using a 3 in the 6. I'm using 3 3s. You don't know 3 3s really. So we're going to avoid the overlap. But 9 and 4. We know 4 works. We know 9 works. So 9 times 4, 36 would work. You can't start mixing and matching. You get all sorts of bigger factors. But if we want them all, you don't want to randomly sit there and try to guess what they all are. You want to be organized. When I'm teaching algebra and I'm trying to teach factoring, trying to teach something that might look like x squared plus 218x plus 432. And you're supposed to factor it. First times first is x squared, so the only way to make x squared be x times x. Since those two signs are both positive, we need a positive and a positive. Last times last is 432. We need to make 218 in the middle. So I would go over and list all the possible ways we can multiply the factor of 432 and see if we come up with which ones add up to 218 in the middle. Okay? But I want to make a list of all the possible factors. And I don't want to miss it. So what I do, if it's 432, I would start with 1 times 432. And we know 2 works. So 2 times, take half of that, we get 216. That's 2 plus 216 is 218. So it'd be x plus 2, then 216 right there. And that would make the factor. But you know what? I still would have stood along. That's because I have a little bit of OCD. Now list them all. But then we know 3 works. So this is going to be 3 times, let's see, 3 times 40, 44. No, that's not. That's 100, you got 1, 3, 132, 4, 12, 144. More. 4 times 108. 5 doesn't go. 6 is going to work. And that's going to be 6 times 72. Yeah. 7. I didn't give you a rule for 7 because the rule for 7 is a little complicated. When we get to the rules of division, I'll show you the rule for 7. We see 8. Well, 432, the only way to test it, it's the last 3 digits. There's only 3 digits. 8 times, that's going to be 54. So 8 goes into 4, it doesn't. So you go to the tens place, 8 goes into 43 5 times. That's 40. Since it's in the tens place, it's 400. Subtract, we get 32. 8 goes into 32 4 times. So 8 times 54. 9, we know 9 works because we've added up to 9. So 9 times. So if we divide that by 9, that's the 40, 36, 16, so 2, 48. Again, my OCD, check, trust myself. So 9 doesn't go into 4. So there's nothing in the hundreds. So we're over in the tens place. 43. 9 can go into 43 4 times, giving us 36. So that's 360. Subtract. That leaves 72. 9 goes into 72 8 times. 9 times 48. It doesn't end in a 0, so it's not 10. 11. Well, if 11 were 11 would have to break down one of these. And it's not 11 is not going into 48. Well, so we know that 3 works, and we know that 4 works. So 12 is going to work. Okay. So 12 is going to work. 12 times. And let's see, that's going to be 12 times 36. Yep. 13, no. 14, 7 didn't work. So for 14, in order for 14 to work, which is 2 times 7, so we would need the 7 to work. Because 14 is 2 times 7. Since 7 doesn't work, 14 is not going to work. 15. Since 5 didn't work, 15 is not going to work. 16. 16 is 8 and a 4. 2's. So 8. Here's how you know 16 is going to work. You have an 8. 54 is still even. So I can break that down and take out a 2, and I get 16 with the 8. 54 divided by 2 is 27. So it's going to be 16 times 27. So I was starting with this. I had 8 times the 54, and the question is 16 going to work? Well, this is 2 times 27, and there's my 8. 8 times 2 gives me that 16. And then times 27. 17, no. 18, it's even, and 9 works. So where's my 9? Here's my 9. I have 9 times 48. So I'm looking to see if 18 works. So this is 9 times 2 times 24. That's I'm going to get 18 times 24. 19 is prime node. 20, it doesn't end in a 10. 21 needs a 7. No. 22 needs an 11. So no. 23 prime, so no. 24. I've already got the 24. So the next one would be 24 times 18. So once you start with the reversal, you have every single one. The reason why that's a recent problem is because a lot of people, and in this class with so few of you, that's not going to be good because a lot of people might be all of, I don't know, they give up. It's not a hard question. It's just a tired. I found 4 of them. Isn't that enough? Question is find all of them. And that just means you got to organize and do it one at a time. And you just have to go through all this. Sometimes it takes brute work. It's called, how do you solve this question? You got to use brute force. It's like putting a square peg in a round hole. You got to force it through and make it work. You got to use the blood, sweat, and tears to get it done because there's so many of them. But it's not hard work. It's just a little long. You know what? Sometimes on Tuesday, you're going to be wishing, oh, I wish we were doing what we did last week. Because that was no big deal compared to what next week might be. One of my favorite college classes, the one I know I got an A in, was when we had to do 250 step proof. And it was just logical. The next step made sense from the last step. Now, I wouldn't want to grade that from a whole bunch of students, but it made sense to me because it was one step at a time. It was brutal, but it made more sense than something that was purely theoretical. Plus, I got to brag about it to a bunch of students. Oh, yeah, my proofs were like, I was never put it on the wall. Okay. Two adult siblings are not always able to visit home at the same time because of their schedule. One is able to visit every 20 days, and the other visits every 30. During the course of the year, 365 days, how many times will both siblings be visiting on the same? So we could list out from 1 to 365 and count and circle 1 in red and the other one in blue. Count by 20, count by 15. And when they have the same circle, that's when they're visiting and they count how many times they have the same circle. That's brute force. And maybe you teach 5th graders. Here you go, piece of paper. And you maybe give them different numbers or sort of like a month. Somebody can visit every 3 days, the other one can visit every 4 days. How many children do they get to visit in college? You make it a simpler question. And you make them do it, give them an actual calendar and you have them do it. Brute force. And then you teach the concept. You're looking for common multiple. when does, or how many times can 15 and 20 go into the same number? From 1 to 365. So the only time they're going to overlap, and you can pick one from 1 to day 365, and you can list player number 1, the 20 days, or list player number 2, the 15 days. Pick one, tell me, 20 or 15? 15? Thanks. So the first day player number 2 is going to visit is on day 15, and then day 30, and then day 45, and then 60, 75, 90, 105, 120, 135, 150, 165, 180, 195, 210, 230, 225, 240, 255, 270, 295, 285, 300, 315, 330, 345, 360, and 365 off. So I only listed, he lists one of the siblings. Now, when does brother with the or sister with the 20 days gonna actually go into them? Would the 20-day person be able to meet up on the 15th? 20 days will not go into 15. Would 20 days meet up on the 30? Nope. 45? But 20 goes into 60. So it would take 2 months before they're there on the same day. And then 20, 20, nope, 20, nope, 20 goes in there. So every 60 days of it. So you start to see the pattern. So 1, 2, 3, 4, 5, 6 times. Into the pattern. But how do you even get started? Now it's the word problem. What in the world are they asking? Yeah, but how does that even? I'm looking at that. I'm going, I can see where a student. I mean, I saw when I first read that. I'm going, huh? It's not well written. First of all, you got to get past the part that it doesn't matter. 2 adult siblings, I don't know. That's frivolous. Not always able to visit home at the same time. Whatever. Because of their schedules. Who cares? Okay. Able to visit every 20 days. The other one's able to visit every 15. And then it goes another during the course of the year, 365 days. How many times would both siblings be visiting on the same day? And never said common multiple. Because that's what we found. All the common multiples were 20 and 15. That was common, quite all the factors. This was common multiples. And I never use that word. So you need to sometimes, when that work phone comes around, all right, simplify. Let's say it was every 3 days for one and 2 days for the other. So 3 days, can't make it, 2 days. That's 4 days, the next one is 6. 2 and 6 will meet up. Okay, what's gonna happen? What is gonna happen again? Well, when the 3 is gonna be even. So the next time 3 is at 6, then it's gonna be 9, this will be at 12. So when they match up, every time the 3 can be an even. Every time that 15 is gonna be a multiple that goes into, or that 20 can go into. So every 6 will lead to 4. It was 4 times 5, 2, 2 and 5. 15 is 3 times 5. So the answer is going to need 4, 3. It already has a 5. So they're going to be able to meet up every 12 times 5 every 60 days. There's your common multiple. Because that's what they'll go into either. And that's another thing that you start working with. And you're going to have somebody, you're always going to have somebody in class that goes, couldn't you just? Always. And you're going to have to realize, yes, however, the other 15 people in the class aren't going to adjust. So hang on to that thought. We'll talk about it. Yes. Try to validate at the same time. Not everybody else is going to see it. So they do want that validation because they're on the right track. Okay. Back at noon, and we're going to delve into all the notes. Everybody got the notes? Okay. 6. Because who knows, maybe they started in February. So from that day till the next February, it still would be 6 times.